1950s, ocean scientists began using scuba equipment to observe firsthand the underwater world. Their observations raised questions about ocean ecology that no one had even thought to ask until seeing the communities in action. But what about scientific observation in the deepest parts of the ocean where it is impossible to dive? Deep-sea explorers had to find a different approach. They brought the bottom of the ocean up to the surface.
We, starting nearly half a century ago, updated or modified a method that reputedly was used by Aristotle 2,500 years ago in the Aegean Sea when he was tutoring Alexander. And in order to do that work, we use a frame, a metal frame, which we can hang from a large wire. But below that metal frame is a chain bag, a metal chain bag, and it is limp. And the reason we use a chain bag is so that if that instrument, that bag, that box gets hung up on the bottom, what we have caught in it won't dump. Clever, but very simple.
On the deck of the ship, teams emptied the dredges and sorted the hull into piles of like with like. Only occasionally finding the odd sample that didn't seem to fit anywhere. They brought the samples back to Scripps and submitted them to a battery of geochemical tests and analysis. But some rocks became part of a special collection managed by Robert L. Fisher, the man who dredged the rocks from the deep ocean floor.
This is a mid-ocean type basalt. This is something that came to the seafloor as magma, but it baked samples of sediment upon it. It was that hot. And the thing that's interesting about this particular thing, you see a second coming, so to speak. You see within that tube in the rock, there was some more magma that came in and made a second approach.
This is a similar sample from deeper in the Earth's crust. Fisher took a drill sample from it to test the velocity of sound through it. Useful information for seismic refraction work. But the pride of the collection is a pristine sample of peridotite.
It's a beautiful bottle green, but the thing that's unique about this and means it really belongs in the Smithsonian, this rock, is that it's utterly fresh and little or nothing in it but magnesium and the silicate.
But the real value in Fisher's rock collection is what it told geologists about the movement of the Earth's tectonic plates.
Here in my right hand, I am showing the oceanic rocks moving down. And here in the left hand, I have the peridotite from the island arc lying right above it. So here, right here, you have seen subduction in action.
For the first time in history, a scientist could actually hold in his own hands hard evidence that one tectonic plate was diving beneath another. No scuba gear required.